Get back from BC, we will do a lab looking at these solutions. So for now, we'll flip this over and we're going to talk about solubility curves next. So solubility curves look like this, and you'll see a graph where you have concentration in grams per 100 milliliters of water and temperature on the x-axis. So as you increase temperature, you can increase the amount in grams of solute. These are all examples of solutes dissolved in 100 milliliters of water, which would be the solvent. So we're going to look at a few examples of these and how we use the solubility graph to tell us information about the different solutes. So here, solubility, here's our definition. You might want to highlight that or something like that. It's the amount of solute that dissolves in a given quantity of solvent at a specific temperature. So when we give an example of solubility, we have to include all of these pieces. Our grams of solute, our volume of solvent, in this case it's water, and the temperature. So answer the following questions using the attached graph. Your graph is this one. There's also one on the back that you'll need for some of these homework questions. So let's look at A. State the solubility of each of potassium chloride and sodium chloride at 20 degrees Celsius and at 60 degrees Celsius. So on our solubility curves graph, here is potassium chloride. That's this one, so it's this line here. And if we want to know what the solubility is of that at 20 degrees Celsius, we're going to look at this graph, find 20 degrees Celsius. So we can follow that up, and it's right here. Put your pen on it, use your ruler to go sideways and sort of think about where that comes out. Using this, you're going to have to make a bit of an estimate because this graph doesn't have little graduations, but I would say that that is maybe like 6 or 7 grams at 20 degrees Celsius. So when we state this, remember it's grams per milliliters of water at the temperature. So potassium chloride, KClO3, we'll do that one first, is 6 or 7, sort of depending on how your graph looks, 6 grams per 100 milliliters of water at 20 degrees Celsius. And then it also wants it at 60 degrees Celsius. So we can pull this back, look at 60, follow 60 degrees all the way up to when it hits the solubility curve. Oops, sorry. For potassium chloride, use your ruler to find the concentration. So that comes out about there. So we're looking at about 25 grams. So then here, the second half of this is 25 grams per 100 milliliters of water at 60 degrees Celsius. Then we can do the other one. So we're looking at sodium chloride this time. So NaCl, again at 20 and 60 degrees. This is going to be a lot of practice using the solubility curve. So we have to find the curve for sodium chloride. Sodium chloride's right here. So it's this one. It's pretty straight. It goes up a little bit here at 20 degrees Celsius, so temperature 20. We follow it up until we meet the line, which is right there. Comes over, and it's going to be about 36 grams maybe. So take your best guess, 36 grams per 100 milliliters at 20 degrees Celsius, and then 60. So again, here's sodium chloride is this line. 60, we can follow 60 up. There it is there, which is probably about 38. So if we follow this over to about there, so 38 grams roughly. 38 grams per 100 milliliters at 60 degrees Celsius. As long as you're close then you would get the marks for it on like a test or a lab. If it's way off, then you would get it wrong. But if it's off by 1 or 2 degrees grams, just based on how you read the graph, because there aren't extra graduations, that's totally fine. Okay, B. Generally speaking, what effect does an increase in temperature have on the solubility of a salt? So salts are just any ionic compound. And so let's look at this. As we go from a low temperature over here to a high temperature, what does it look like all of the lines are doing as they go from left to right? I'm going to give you guys a second just to think about that. And think about why. Okay, so hopefully you've come to the conclusion that as temperature increases, solubility also increases. So let's make a note of that in B. So an increase in temperature equals an increase in solubility. And it asks how that relationship happens. The reason is, as you add temperature, you're adding heat. Heat is a form of energy, and when you have more energy added to the system, you can break the bonds that are between the elements in the ionic compound so that they come apart into ions. So when you add heat, you add energy, which helps break the bonds in solids to dissolve them. A bond happens because it requires less energy for two elements to be bonded together. That's why bonds happen. So to get a bond to break, you have to put energy into the system. Otherwise, it's more stable as a compound. So C, which salt has the greatest change in solubility with an increase in temperature? So here we're looking for which line has the steepest curve. Hopefully you've found that it's potassium nitrate. It has the steepest curve, so as temperature increases, it has the greatest effect on its solubility because the solubility increases so rapidly with an increase in temperature that's not as drastic as some of these other ones. So potassium nitrate is the answer. Potassium nitrate, KNO3.